All right, let's dive into one of the biggest questions imaginable. We're going on a journey to find the edge of, well, everything. It seems like a simple question, right? If the universe had a start, a big bang, then shouldn't it have an end? A physical wall or boundary you could actually point to? Well, the answer to that is going to completely flip what you think you know about space itself.
I mean, think about it. Everything we know has an edge, a boundary. Your house has walls, a country has borders. But what about the universe? If the universe is literally all of existence, what could possibly be on the outside? The very question creates this logical knot that philosophers and scientists have been wrestling with for centuries. So our common sense, our intuition, gives us a pretty straightforward answer. We know the universe kicked off with the Big Bang about 13.8 billion years ago. And if it's been expanding this whole time, then surely there must be a leading edge to that expansion, right? A finite boundary out there somewhere? But here's the kicker. What if that cosmic common sense is actually leading us down the wrong path entirely? And that leads us to a pretty radical idea. What if the edge of the universe isn't a place at all? What if it's just an illusion, a trick of our own limited perspective? To even begin to understand that, we have to look back at some of the key discoveries that completely shattered how we used to see the cosmos. You know, our modern picture of the universe is really built on three huge moments. First up, 1915, Einstein drops his general theory of relativity, basically giving us the playbook for how gravity and space itself work. Then, fast forward to 1929, when Edwin Hubble makes a discovery that puts Einstein's playbook to the ultimate test. And then, 1998, a year when a totally shocking observation turned everything we thought we knew on its head all over again. So what Hubble found was just incredible. It wasn't just that distant galaxies are flying away from us, they're all moving away from each other. This isn't like pieces of a bomb flying out from a center point. Imagine drawing dots on a balloon and then inflating it. The dots all move apart, but there's no center to the expansion on the balloon's surface. That's what's happening. The fabric of space itself is stretching, and it's carrying all the galaxies along for the ride. And that was the first huge clue that our whole explosion idea for the Big Bang was probably wrong. Okay, so that forces us to ask some big questions about the Big Bang. If it wasn't an explosion in space, but an expansion of the space itself, what does that even mean? Well, it turns out the evidence we've found since Hubble creates a massive problem for that simple explosion idea. And here's where we see a huge clash between what we'd expect and what we actually see. If you have a bomb, you get a super hot center, and things get cooler as you move away. Simple. But when we look at the leftover heat from the Big Bang, this thing called the cosmic microwave background, we find something mind-blowing. The temperature is almost perfectly, uncannily uniform everywhere we look. And that raises the million-dollar question. How on earth did two opposite ends of the universe, which are billions of light years apart, end up at the exact same temperature? Nothing can travel faster than light, so there's no way they could have communicated to even out their heat. A simple explosion just can't explain it. This tells us that the universe is fundamentally way weirder than we imagine. So the answer might not be about finding a physical edge at all. It might be about understanding the universe's actual shape, its geometry. Yeah, the very shape of space could be the key to unlocking this whole mystery. Here's a great way to think about it. For thousands of years, people were positive the Earth was flat. Why? Because from where we stand, it looks flat. You can't see the massive planet-sized curve. So what if we're making the exact same mistake with the universe? What if it seems infinite and flat to us, but it's actually curved in a way we just can't perceive from our little corner of it? And this idea about shape has some seriously wild consequences. Let's say you get in a spaceship and just fly in a perfectly straight line. If the universe is flat, like a sheet of paper, you'll just keep going forever. But if the universe is curved, like the surface of a sphere, that straight line will eventually bring you right back to where you started, just like flying a plane around the Earth. You never turn, but you end up back home. And this leads to the most mind-bending part of all. Think about the surface of the Earth. It's finite, right? There's only so much land and sea, but there's no edge you can fall off. A curved universe could be just like that, finite in size, but with no boundary and no center. Every single spot in the universe could be just as much the center as any other. Okay, so what about the edge that our telescopes see? Well, that's something different. It's called the cosmic horizon. And it's not a real wall.
It's just the furthest we can possibly see, because light from beyond that point hasn't had enough time in 13.8 billion years to reach us yet. It's exactly like the horizon on the ocean. The further you sail, the further the horizon moves away. It's a limit of our vision, not a physical end. But wait, because the story gets even weirder. It turns out the expansion of space isn't slowing down like you'd expect. It's actually speeding up. And the mysterious thing pushing it all apart is something we know almost nothing about. We call it dark energy. Yeah, back in 1998, the world of cosmology was just rocked. Scientists were looking at these distant exploding stars, these supernovae, to measure how much gravity was putting the brakes on the universe's expansion. But they found the exact opposite. Instead of slowing down, it's hitting the gas pedal. So they gave this mysterious force a name, dark energy. It seems to be some kind of energy woven into the fabric of space itself, acting like an anti-gravity force that's pushing everything apart. And here's the truly shocking part. It makes up almost 70% of the entire universe. Most of the cosmos is made of this stuff we can't see and barely understand. Now here's the real puzzle with dark energy, the thing that keeps physicists up at night. Normally, if you take something like air and put it in a bigger box, it spreads out and gets weaker, right? It dilutes. But as the universe expands and gets bigger, dark energy doesn't dilute. Its density stays the same. It's as if creating more space creates more of this energy out of nowhere. And that breaks all the normal rules. So when you have these huge, glaring puzzles, like the perfectly even temperature of the universe and this weird, non-diluting dark energy, it forces scientists to think way outside the box. They've started exploring some truly wild ideas that go way beyond the standard Big Bang theory. And these theories get pretty mind-bending. They suggest that maybe, just maybe, our universe isn't the only one. We could be just one small part of a vast cosmic ecosystem, a multiverse. You've got ideas like the Big Bounce, where our universe is in an endless cycle of expanding and collapsing. And then there's the idea of bubble universes, where countless other universes are constantly popping into existence. So let's walk through what one of these cycles could look like. First, imagine a huge, vast hyperspace that's always churning out new universes, like bubbles in boiling water. Then, some kind of vacuum energy inside each bubble makes it blow up really fast. And that's what we call our Big Bang. After that, a couple of things could happen. Maybe the universe expands, then collapses back on itself and bounces into a new Big Bang. Or maybe it expands so much that it just rips apart and its raw ingredients get recycled back into that hyperspace to create new universes. In that picture, our entire cosmos is just one little phase in an eternal cosmic story. So after all that, we come back to our first question. Where is the edge of the universe? And maybe the answer is that we've been asking the wrong question all along. Maybe the search for a physical wall out there in space is missing the point. Perhaps the real edge is the edge of our own knowledge. And the amazing thing is, the more we learn, the further that edge pushes back, revealing a universe that is so much stranger, so much bigger, and so much more wonderful than we could have ever dreamed. The real journey, it seems, is just getting started.